Okay, friends, let's start. I'm going to meet everyone. Okay. So, my dear friend, we discussed last few classes. We discussed about few distributions. When we identify the data is having random variables. What kind of a random variables? Discrete random variables. So, we looked into the Bernoulli. We looked into binomial. We looked into Poisson distribution. We looked into geometric progression, and there are so many. Now that is good enough for us for our understanding, and from utilization perspective, that is good enough for right now. Now we'll move on to continuous random variables. What are the various possible distributions are available for this continuous random variables? The first and very important and very widely used distribution is normal distribution. Before getting into the normal distribution, let us look at this continuous random variable. So we discussed a lot about this continuous random variable. Now I'm trying to take an example. What is an example? Exam is your commute time. Your commute time to office or college, whatever it is. This is an example. So I'm defining my random variable x. I'm defining my random variable x as my office or college commute time. Let us say you are taking about 50 minutes to reach to office. Just be with me. Okay. Now, what is the probability of me reaching to the office exactly at 50 minutes? Anyone would like to answer this question in the group chat? What is the probability of me reaching to office exactly 50 minutes? Depends on traffic, what parameters we need to look at, what else? So even let us assume you have given you all the theoretical and the parameters and the traffic, everything is clear, the mode of transport, everything is taken care. So is it really possible for anyone exactly to be there at exactly 5.0000 something like this, or 50 minutes something like this, or it is something like 50 minutes point 10 seconds, or it could be 49 minutes 55 seconds, something like this, because this is the time we're talking about. This my random variable is the continuous random variable. This is continuous random variable. So that means continuously variable is changing. It's not like with respect to your discrete random variable. So for example, you are rolling a die. Okay, you are rolling a die. So what are the possible values when you roll a die, friends? 1, 2, 3, 4, 5, 6, right? These are the 6 phases that the die has, and in each die there are the circles starting from 1 to 6. Okay. Now what this is my x. This x I am defining it as rolling of a die or throwing a die. This on this y-axis, I wanted to capture the probability. What is the probability of me getting 1? Please respond in the chat. 1 by 6. So let us assume that this is 1 by 6. Okay, this is 1 by 6. What is the probability of me getting 4? 1 by 6. What is the probability of me getting 6? 1 by 6. So whatever it is, the value is going to be the same. The probability is going to be the same. So the distribution which I'm going to get is something like this. Sorry, I am not a great drawing person or painting person. So basically, this is called uniform distribution. This is called uniform distribution. And here, okay, this example, uniform distribution, this rolling of the die can be used for discrete as well as for continuous also. Depending on the context that we are using it. Depending on the context that we are using it. Okay. In case of this, here the values, the possible values of x. What is the possible value of what is the x here? In this context, is x is getting 1 to 6 when I throw a die, right? So here your possible values are 1, 2, 3, 4, 6. So what is the probability? Okay, in which is there any possibility that the value between is there any possibility that the roll is the die is going to show 1.5? Is there any possibility that roll is going to show 1.5? No, right? It is not possible. So that means the probability is constant at the value 1 and constant at value 2. Whereas in case of continuous random variables, the probability is constantly changing. Let us discuss little more deeper into this. Let me go up and talk from this example perspective. What is this example? Office commute time. Okay. Now I am going to introduce 2 terms. One term you already know. Second term I just wanted to introduce right now. There is something called CDF versus something called PDF. Can anyone define what is this PDF? We talked a lot about this PDF. This is applicable only for continuous random variables. What is the probability function called for the continuous random variables? What it is called as? You are forgetting the subject. This is probability density function. In case of discrete, it is called probability mass function. See, so many times I'm repeatedly telling, but still you guys are not responding. CDF is cumulative distribution function. Cumulative distribution function. Let us go a little deep into these two concepts. Okay. Now, this is my x axis. This is my x. This is my cumulative probability. Okay. Similarly, this is my x, this is my probability density. Okay. Now, because in case of random variable, in case of continuous random variable, the probability which I simply asked that what is my goal here, my commute time, this x is my office commute time, x is my office commute time. It takes about 50 minutes. Okay. Now I'm asking you guys, what is the probability of x equal to 50? Ideally, answer is 0 or very less, because my variable is continuous random variable. It is constantly changing. Okay. So at any given point of a time, the probability is going to be 0. Guys, are you with me? Did you get this point clear? In case of a discrete random variable, at that given point, that is the value at the value 1, when I throw my die, is a definite situation that there is no, the value of the probability is not going to change from 1 to 2, because there is no 1.5, there is no 1.6, there is no 1.8. But in case of a continuous random variable, the 55 minutes time is either it can be 49.555 cents seconds, or 49 minutes 59 seconds, or 50 minutes 05 seconds, like this. So continuously, given the timeline perspective, it is continuously changing. So at a given point, if I want to calculate the probability, it is practically 0 or very less. This is the problem with the continuous random variable. Did you understand what is the challenge that we have with respect to the continuous random variables? Please respond. Guys, this is the basic fundamental question. Okay, many people don't have this much of clarity. They may give you some wonderful definition of the textual definition from the textbooks about continuous random variables and discrete random variables, but in reality, this is what it means. You need to understand this. If you understood this difference, you can you can solve any business problem. Okay, because the values are continuously changing, or the probability is 0 or practically very less, it is not wise enough to define probability at a given point for continuous random variables. Rather, we will talk in terms of intervals. We will talk the probability in terms of intervals or in terms of range. What is that range? Now I am creating my probability distribution function. I'm writing like this. My x is like this. Here I am trying to write my probability. So now what I do is I define the range, something like 35 to 40 minutes, 40 to 45 minutes, 45 to 50 minutes. 50 minutes to 60 minutes. Now, even when I define a range like this, I can calculate the probability, right? Probability is nothing but number of favorable items by total number of items, right? So from when my commute time is 35 to 40, if I look at it, so some days because the traffic was not there, or I might have used little better vehicle or with little speed vehicle, so that I will be able to reach the office less than less than 40 minutes. That is somewhere between 35 to 40. How many times probably I might have gone? Maybe few times. Given a month time frame, if I calculate, if I want to do this, let us assume that my probability is coming somewhere around 0.2. That means probably 4 or 5 times I might have gone to the office less than this or within this interval time. Okay, are you understanding? Are you with me, my dear friends? Please respond. Do you want me to explain once again? Now let us assume that on some days I mean I'd been to the office within this 40 to 45 minutes time frame. Okay, and the probability, the way I calculate is coming, let's say, around 0.3. Most of the time, because of the various conditions, because of the conditions that I will be going through, I was able to make out my office somewhere between 45 minutes to 50 minutes. This is the majority of the time. So my probability is going to be 0.4. How do I calculate this 0.4? Number of times I went to the office within this range, 45 to 50 minutes range, divided by total number of times I went to the office within the same time, with the total time. That is resulting you into this probability. I am not calculating the probability like this at a given any point. Rather, I am trying to calculate the probability between the intervals, between the range. 50 to 60 is something around 0.1. What is the sum of this? Sum should equal to 1. Probability of all the possible occurrences will be is equal to 1. That principle you cannot forget. That is always given to you. Okay. Are you with me, my dear friends? Is this point clear? Okay. Moving on. Now, same x. Now I want to calculate the cumulative probability. Okay. In the cumulative probability, excuse me, I am taking the upper range of the value. So I am taking this as a 40, because till 40 I know what is the probability. Okay. Then taking 45, then I'm taking 50, then I'm taking 60. I can also take here, or rather I can insert another here, less than 35 I can insert. That I will come to later. Okay, but let me look at this. Okay, so till 40, what is my probability? This is my probability. This is 0.2. So that means, what is the probability of me commuting to the office less than or equal to 40 is 0.2. The probability of me reaching to the office less than or equal to 45 is this 0.2 plus this 0.3, which is your 0.5. What is the probability of me reaching to my commute time is less than 50? 0.5 plus 0.4, 0.9. What is the possibility that my commute time is less than 60? Is 100%. 0.9 plus 0.1, which is 100%. Is it clear to you guys? Now, I am drawing a picture. I am going to draw a picture here. This is my commute time X. This is my cumulative probability. Okay. So, I am starting somewhere here 40, 45, 50, and 60. There is something called less than 45, or sorry, less than 35. What is the probability of less than 35? Anybody would like to answer this? What is the probability of me? Yes, exactly, like 0. That is 0. So it is not going to happen at all. That's what it means. 0 means it is not going to happen at all. So for this data point is sitting here. Then 40, it is 0.2. Let's say this is 0.2, this is 0.45, this is 0.9, this is 1. So it is going to be here. Here. 45 is going to be here. 50 is going to be here. 1 is going to be here. Generally, the curve is going to be something like this. Oh, come on. So generally, the curve is going to be something like this, guys. Okay. Because I'm not good in terms of scaling these things over here, but this is how the curve, your curve is going to be. This is called cumulative probability distribution. Suppose if I want to know what is my probability of me reaching, let's say, 48 minutes. What is the probability of me reaching to the 48 minutes? Accordingly, you have to put it like this. You can go here, you can find out the value, and that is how you can say this is my probability. Are you with me? Now, probability distribution function. So this is called, so far what we studied is, this is called CDF, cumulative distribution function, because your probability is adding up and you define the range and you have taken the upper range value and you plotted the information. So this way what happens is, I don't have any clue how the distribution is going to look like. That means, is it a uniform distribution, or is it a symmetrical distribution, or is it a cyclical distribution? I cannot find it from CDF. Okay, but there is a excuse me, guys. There is another way of, okay, sorry. Another way of representing the data, probability. What is that another way? Like this. This another way is, this is my X. This is my probability density. This is my probability density. So when I try to calculate the probability density, this picture, this graph will be reflecting something like this. something like this. This one is representing to your 40, and this point representing to your 60 minutes. So you're oscillating between 40 minutes to 60 minutes. So this way, if I want to know, so let us assume that this value is, let's say, 0.3. From understanding, from illustration perspective, maybe picture is not right here. So at 48 minutes, me reaching to the office, office is, the probability of me reaching to the office is 0.3. So where is 48 here? 48 might be here. Okay. So here I can get the 0.3 by simply looking into this axis. But here you will be calculating area under this curve. This is equal to your 0.3. In case of PDF, if you want to calculate if you want to find the probability, you always calculate the area, and area will give you the probability. In case of CDF, at that particular point, if you compare that with respect to the y-axis, that will give you the probability. So which one is effective? This one is effective or this one is effective? I'm asking question, guys. Is PDF better or CDF is better? PDF is better because it is not only giving me, by looking into the area, I will be able to find out the probability. Here, I don't need to do any math, but the problem here in the CDF is, I do not know the nature of the data. I do not know. Here, I looking into this, I can talk about, this is symmetrical. Okay. One minute. Sumant is asking question. Can I repeat the PDF once again? Give me a few seconds. Let me draw these two pictures here. Okay. Here the picture looks like this. Excuse me. Here the picture looks like this. This is less than 35. Somewhere here you have, this is 40. This will be like your 60 minutes. Here this is 40. Here this is 60. Now the question may be there in our mind. The question that will be there in your mind is how the values have changed. Here the values are cumulative. That means this value is standing at 0.2. It might be somewhere here it is 0.5, somewhere here it is 0.9, and somewhere here it is reaching 1. Okay, because it is cumulative. Here it is about, it's not cumulative. This probability density function perspective. Okay, it is the value which you are trying to plot. There will be increase that goes around and comes down. Okay, So now if I want to find out what is the probability of me coming to the office for 48 minutes, this is 48 minutes here, I can get it to from this value. Maybe this is 0.3. But if you want to find out the same thing here in this probability density function, okay, here this is your 48 minutes, okay, and the area under this will give you the same 0.3 value. How? Here you are able to calculate the probability and adding cumulative. Here you have a density function. There is some function. Okay. What is that function? In case of continuous random variable, the function PDF is written as f of x equals to r. You can write this way, or you can write it as f of a capital X equals to small x. The formula is 1 by sigma square root of 2 pi multiplied by e to the power of half into x minus mu divided by sigma whole square. Very, 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 very important. The values which you get is going to create this curve. Are you with me, my dear friend? Let us look at this little more in a different way. How? Suppose I am trying to, so let's say I am trying to calculate my x value. Let's say x value is 0. Okay. So that means wherever x, I can substitute that x. Rather, in this example, my x value is 40. I'm using my x value as 40 minutes. So what is this? This is nothing but 1 by, okay, sigma into square root of 2 pi, okay, e to the power of half into my x is 40. What is mu? Mu is average of all that from 40 to 60, whatever average you are getting, that is the mu. Let us say that is some number. I'm putting something as 50 divided by my sigma whole square. Okay. So here, what are the values of my mu and what are the values of my sigma? That is one important question to be answered. Let me change this 50 value. I'm writing this as mu. I'm writing this with red color, sigma. The reason why normal distribution is very important is you know the sigma and mu well in advance. What is this? I want to tell you something here. So sometime back I told you, when I'm drawing this one, what does it mean? This is nothing but I'm talking about histogram. I am sure you might have forgot about this. It is all about whenever I'm drawing this picture, it is representing histogram. Okay. At the peak, what is this? What is my mu? What is this? When do I say it is a peak? This is at my mu, right? This is at my mean. This is my average. So my mu equals to 0 and my sigma equals to 1. Long back we discussed about this. The reason why I'm talking about is area under this curve. If this is symmetrical, absolutely symmetrical, this side and this side, area under this curve is equals to 1. Okay, this is where you need to know the coordinate geometry. Okay, let us not go there and prove why it is 1, why can't it be something else, because it is already proven. Let us, it is again, it will take one more class extra to prove all that part, but right now it's a very simple logic. Your probability is changing from 0 to 1. Your probability is changing to 0 to 1, it is changing in this context. Okay, this is the area. So sorry, I can't represent this way. This is not the right representation. Rather, I can say the area under this curve is equals to 1. That is the reason normal distribution has become very popular, because this is all about probability distribution, right? This entire information is probability distribution. Probability changes from 0 to 1. So naturally, area under this should become 1 only. Are you with me? So in this context, okay, I can subtract my mu value equals to 0 and sigma equals to 1 and calculate my this function when x equals to 0. I can subtract my f at x equals to 40. I need to have this information for some value to my mu and some value to my sigma, some number. So given this kind of values, okay, you will be subtracting in this equation, in the above, in this equation, okay, and you are calculating your probability. Those values you actually plot, based on that you actually plotted this graph. This is PDF. Suman, did you understand how you got this kind of a curve? So then the question may also come, how do I, what is this formula is all about? Who derived this formula? Statisticians, they spend their lifetimes and they have come up with these kind of a formulas. Okay, they have done enough research, and then that is how they have gifted to the world that these are the formulas that we can use it. So when you have any data, that means there is a business problem which you are trying to solve, and either you may have the data for the business problem or you may be collecting the data for the business problem. In both the scenarios, after you collect the data, now it is your responsibility to check whether this data is following what kind of I mean, is whether this data is close to which kind of a distribution. Is it close to normal distribution? Is it close to Poisson distribution? Is it close to Bernoulli distribution, or binomial, or negative binomial, or exponential, or whatever? If it is, why do we need to do that? If it is matching to any of these distribution, it is easy for us to figure out the probabilities, because there are already enough formulas were defined for these distributions. That means we know how to calculate the probability. When you know the probability, then you can talk about what is the certainty level. That means I will be able to predict well in advance what is the certainty level, and accordingly I take certain decisions on top of it. Hope this is clear to you guys, where I'm heading towards. Guys, this you will not find it in any textbooks. What I'm explaining right now. This comes out of the experience. Are you with me? Do you understand the height of sorry, the area under this curve is 1. Now, question may come: why it? I mean, somebody has to prove this, right? Area under this curve. So you know this example. I don't know how many of you remember the integration. What do you mean by integration? Anybody would like to answer this question? What do you mean by integration? You know how the integration symbol is going to look like? This is integration, right? Integration A to B. Do you remember this concept of integration? Okay, silence. So let me explain you. It's a very simple, guys. Integration is nothing but sum. Sum from A to B. See, the S letter, they stretched it something like this, and they have written the boundaries. That is what integration is all about. Suppose here is a curve. This is your curve. Okay. Now, I want to calculate the area under point A, point B. This is point A, this is point B. So what you do basically, how do you measure this area under the curve? Generally, if it is a, what is this kind of a, what is the area of a rectangle like this? What is the area of a rectangle? Let us say this is L length and this is breadth. Area of a rectangle. What is the area? Please respond. LB. L into B. That means length into breadth. Now what we do is we will divide this into a small element with the width as dx. That dx means change in the element x. That means x was here at this point. From here it moved here. Okay, more or less, if I divide this into a small rectangles, very narrow rectangles, it looks like this curve almost looks like a rectangle. Okay, so that means that is represented by dx. Dx means change in the element x. That change is a minute. So between A to B, I can divide these minute elements, n number of elements. In numerous elements, I can divide into. Okay, are you with me? This is important, guys. You need to understand this. Okay, so this area, I know this length, and I know this width. So this length multiplied by this. Suppose this area, I let us assume that I got an area as A1. Like this, so many area strips are possible, right? So many strips are possible. You understand? So this A1 I will be calling it as this length. I am calling it as function x equals to small x. This is this width. I'm calling it as dx. So my A1 is nothing but f of my x equals to at x multiplied by dx. Because there are so many such strips are possible, like this, A2 is also f of x equals to x dx. This x may have value some 0.1. This x may have a value something called 0.2, something like that, because that is constantly changing. Like that, I will be having n number of areas. So what is the total area between A and B? Assuming that you have n such rectangle strips, my area I'm going to be something simple, summation of all. A1 plus A2 plus A3 plus up to AN. That means this is f of my x equals to x multiplied by dx plus f of my x is equal to x multiplied by dx, like this up to n times. This x probably from your understanding perspective, I can write it as x1, x2, something like this, so that it is clear to you. Width is same, dx is same. Okay, height is changing, x equal to x1. This height is changing. From here, as you go up, this height will change, right? This is nothing but, this is written as integral of a to b f of x equals to x. Now I am generalizing it. I am not substituting the x as x1, x2, x3. I am generalizing this, multiplied by dx. This is nothing but your area. Under what conditions? Under this is under the condition of A and B. That means between A and B, I am interested in this f of x equals to x multiplied by dx. That means my height into breadth, which is constantly changing changing for my continuous random variable. Friends, are you getting me? This is also equals to, this is written as probability, this area is written as, this area equals to probability of A less than or equal to x less than or equal to b. Nothing but integral of a to b f of x is equal to x into dx. Okay. Are you with me? Now, what is fx here? Your f of x equals to x is nothing but, for the continuous random variable, if the data is following normal distribution, let me repeat, if the data is following normal distribution, then the equation for f of my x is nothing but 1 by sigma square root of 2 pi multiplied by u to the power of half into your x minus mu divided by sigma whole square. For various type of distribution, this f of x is equals to x is going to change. For normal distribution, this is what it is. Please remember, this is what the understanding that you should carry when somebody is telling that the data is following normal distribution. Are you with me, my dear friends? Am I making sense to you guys? Or is it going on top of your head? One more question here in the same above screen to you guys. What is the area? What is the area under A? So area under the line B. This is line B. This is line B. This is line A. Can anyone tell me what is the area under line A and line B? Zero. Exactly. Because area under any line is zero. See, guys, you all studied all these things during your 10th standard or plus 2. You just forgot. Or rather, see, this is called being clear in fundamentals. And these are the things which make the difference to make a business decision. It is not about your programming. It is not about your R and Python programming and solving the problem. This understanding of the mathematics into the reality of the situations and where these conditions are applicable, that makes you a wonderful data scientist. Programming is a tool using which you can actually do the calculation, because your data that you are going to deal is not a small data. It's a huge data. Okay. So you use the programming to act all these operations onto the data. But if you don't understand these concepts, how can you become a data scientist? People say machine learning. Everybody wants to do project in artificial intelligence or machine learning. And you talk about people, they'll say, oh, I want to do a project in random algorithm, random forest, or principal component analysis. Using principal component analysis, I want to do something. So if you ask a question, what do you mean by generalization? What do you mean by regularization? People don't have any answer. And then they say, okay, they want to do the projects in machine learning. And people learn R and programming, R programming, Python programming. They go into the GitHub and they copy some Control C, Control V code, and they will come over here and they'll write something and they say, yeah, we have done this. That is not data science, my dear friends. This kind of misunderstanding is too much in the society. Okay, and there are many people whom I have seen, even when they get into, and they interview the people to hire the people for data science, they don't even understand what data science is, and they will ask questions. And 90% of the questions comes from either their programming language or or programming. If you really poke them into the statistics dimension, they will hands up. So you have studied, most of you are students. So my suggestion, guys, you are learning the science in the right direction. Spend some time. That's the reason I wanted to. I'm emphasizing many times. Actually, I wanted to give you a good amount of homework so that you guys can practice, but very few, actually 1 or 2 people are doing the homework. So that's the reason I stopped. If you don't practice these things, you will never be able to understand this subject, no matter how great intelligent you are. Okay, all these formulas, there are n number of formulas. You need to remember, there is no shortcut for this. Okay, so the reason why I'm again and again telling the same thing to you guys is to bring up that seriousness in, and it is a wonderful subject, I'm telling you. And that is why you will be paid huge money. If you are 8 to 12 years of experience in the IT industry and you learn these things, you learn the data science, there are some people who are paid 1 crore salary per annum. No other language you will get this. No other, if you learn other languages, you won't get this much of money. Why? Because they know it is not everybody's cup of tea. But if you don't know these things, at least these fundamentals, you will be disabled in your career. That much I can guarantee. The world is changing so dramatically. Without knowing the data science, after 5 years, all of you are going to be expired. I can tell you this. You will become obsolete. But is it easy? It's not easy. You have to spend some time. So try to spend time, try to understand this, listen to the videos or go and read some books, whichever you want. You take the help of internet. Okay. Make your fundamentals strong. After 40 days, I wanted to you guys to really stand up and say, now I'm ready for actual data science. Then me talking about logistic regression, then me talking about decision trees, me talking about neural network, make a lot of sense. And you will appreciate, wow, what a subject it is. Okay, guys, sorry, don't think that I'm scolding you guys. Okay, I'm trying to say what is the importance of this particular subject. Okay, see you guys on Thursday.